Hello everyone, welcome back to Mathverse by Vishal. So in the previous video, we have discussed the important questions from the morning shift of 2nd April, right? So I hope it was helpful to you guys. So now in this video, we'll try to see the important questions from the afternoon shift of 2nd April. Okay, let's see the first question for this video. And this is a question from AOD concept using limits. And it's a pretty straightforward question, but it is one of the most repeated questions of PYQs from AOD. So let us try to see the concept behind it. Now, first thing, f of x is said to be a fifth degree polynomial and also having extreme values at x is equals to 1 and also x is equals to minus 1. Which means, first of all, we can input the conditions that f dash of 1 is equals to 0 and also f dash of minus 1 is equals to 0 because they are the extreme values. So obviously, at that point, derivative should be is equals to 0 since it is a polynomial function. Okay? And along with that, one more important equation is given to us that is limit extends to 0 f of x divided by x cube is equals to minus 5. Now, we know one thing very well. Yesterday also, we have discussed a question based on this one actually. That is, since the denominator here is x cube, right? As you can notice, denominator is x cube here. Now, since the limit of this entire function is existing and also equals to a finite non-zero value, which means definitely for this function or polynomial f of x here, x cube must be a factor, no other way, right? So that is why I'm going to take f of x is equals to x cube multiplied by some other polynomial g of x. I hope it is clear because if and only if you have x cube as a factor to the function of x, only then x cube will be cancelled out and only after that you can say that the limit of this function is going to be existing and equals to a finite non-zero value. Okay. Now, moreover here, since f of x is a fifth degree polynomial, and that is written as x cube into g of x, and x cube is a third degree polynomial, which makes this function g of x as a quadratic polynomial, because totally it must be a fifth degree polynomial, which means the only possibility is g of x must be a quadratic polynomial. So let us start assuming g of x function here. I'll assume g of x is equals to some ax square plus bx plus c. Okay. Now let me input the condition first. That is limit x tends to 0. F of x is what? X cube multiplied by g of x is nothing but ax square plus bx plus c whole divided by x cube. And that must be is equals to minus 5 here. Okay. Now clearly this x cube get cancelled and the remaining part will be limit x tends to 0 ax square plus bx plus c, which must be is equals to minus 5. Okay. And then clearly you can notice that if you input x tends to 0 here, you're going to get c is equals to minus 5. So directly we have one of the required values, that is c is equals to minus 5. But obviously we still need to find out two more values a and also b, right? So for that we have the two important conditions of extreme values, that is f dash of 1 is 0 and f dash of minus 1 is also 0. I think now you know what to do, right? Directly you have the function f of x with you. F of x is equals to x cube multiplied by ax square plus bx plus c. That is what we have taken, but already we have got c is equals to minus 5. Now let me differentiate this one. So we get f dash of x is equals to, either you can expand and differentiate directly or else you can use the UV rule here. X cube multiplied by 2ax plus b. This is f dash of x function plus, and also we have ax square plus bx minus 5 multiplied by 3x square. Now in this, you have to input the conditions that f dash of 1 is equals to 0 implies. So f dash of 1 is going to be 1 multiplied by 2a plus b plus a plus b minus 5 multiplied by 3 is equals to 0. So if you calculate properly, you're going to get 5a and 4b minus of 15 is equals to 0 or is equals to 15. Similarly, you can put the condition of f dash of minus 1 is also is equals to 0. So if you put minus 1, this is going to be minus 1 multiplied by minus 2a plus b plus, again, this will be a minus b minus 5 multiplied by 3 is equals to 0. Okay. And then you can expand this one finally, from which you're going to get this is 2a plus 3a, which will be 5a, and then minus b minus 3b, which will give you minus 4b. And the constant term again is equals to 15. Okay, so you have two equations with you. Equation number one, equation number two. Directly you can add both of them, right? So if you add both of them, what you're going to get 10a is equals to 30 implies a is equals to 3. And if you input this a is equal to 3, but in any one of the equations, you're going to get the value of b here. Okay. So if you put a is equal to 3, I think you get b is equals to 0, right? So you have all the values of a, b, c here. And finally, you can write down the function f of x from here. That is f of x is equals to x cube multiplied by a value is 3, so it is 3x square. B value is 0 and c value is, we have got minus 5, right? So this is your function f of x. Okay. But once you know the function f of x here, which is actually is equals to what? 3x power 5 minus of 5x cube. Okay. So once we know the function f of x here, we can find out whatever he is asking, because he is asking for the value of f of 2 minus of f of minus 2. And I hope you can do the remaining calculation by yourself. Okay. So as you can see, it is not a difficult question. The only simple condition you have to recall here is, since f of x by x cube as limit extends to 0 is existing and is equals to finite value, we can say that f of x will have a factor as x cube. Okay, and by using that logic, it can be done. Right, only proper calculation is required. Okay, let's take the next question. Now, this is a question from once again a quadratic function, or also it can be taken as a question from parabola. So the question is straightforward actually. So if you have the parabola y is equals to x square plus px plus q passing through the point 1 comma minus 1, and also the vertex is at the minimum distance from x-axis here. Okay, that is the important statement we have to concentrate on. So let's try to analyze the question step by step. First thing, uh, straightforward, that is the parabola is passing through the point 1 comma minus 1, which means it has to satisfy, from which you get minus 1 is equals to 1 plus p plus q, which means you have one condition with you. P plus q is equals to minus 2. Let us keep it aside. We will need this condition later in the question. Okay. Now, here this is a standard vertical parabola, that is y is equals to ax square plus bx plus c form. And what do we know about that one? Whenever we have y is equals to ax square plus bx plus c, we know the vertex coordinates of this one, right? Which is minus b by 2a comma minus delta divided by 4a. And in this case, it's an upward parabola very clearly. So the diagram might look something like this. Okay, this is not the exact diagram. It is just a rough diagram. Suppose if the diagram is something like this. Now this is your vertex point. Now the main thing you have to understand here is the distance of the vertex from the x-axis is going to be this here in the diagram. Okay? This is going to be your distance, right? Now that is nothing but the y coordinate actually, which is minus delta divided by 4a, right? The first thing, let's try to calculate that distance from x-axis. Distance from x-axis by using the formula minus delta divided by 4a. Okay. So the distance from x-axis of this vertex will be is equals to modulus of minus delta divided by 4a. And since they are saying distance, I'm putting a modulus sign here. So it will give you modulus of delta divided by 4a. So what is the delta value for this given parabola here, which is clearly p square minus of 4q, b square minus 4ac, right? And whole divided by 4 times of a value is 1 very clearly. So which is 1 by 4 times of modulus of, I can write this as p square minus of 4 multiplied by, but I can put the value of q as what? Minus 2 minus p from the condition number 1. So minus 2 minus p value as q. And if you expand properly, you're going to get 1 by 4 into modulus of this is nothing but p square plus 4p plus 8. Now it is a simple quadratic expression, right? So I can either you can use the concept of maxima minima to minimize this expression, or it's very straightforward, right? I can write this as p plus 2 whole square and plus 4. Okay, this is your distance from x-axis. Now, if you observe the question, they are saying this vertex is at a minimum distance, which means I have to minimize this value. Okay, so I think I got the idea by now. If this has to be minimum, I can say that p plus 2 value must be is equals to 0, since it is a perfect square. P plus 2 whole square is a perfect square of a real number. So if it is supposed to be minimum, then it should be is equals to 0. That is, p is equals to minus 2. That is, when p is equals to minus 2, you will have the minimum distance. And you can substitute back this value in the condition number 1. That is, p plus q is equals to minus 2. So minus 2 plus q is equals to minus 2 implies q is equals to 0. So you have got both the values of p and also q. And at last, they are asking the value of p square plus q square. In this case, it will be 4, which is option 4 here. So once you get the idea of using the vertex concept, then it is a very simple question. Okay. Let's see the next question. Now, this is a question from probability, and this is also not a difficult one, just a proper idea, and writing down all the cases is important. Calculation is also not a lengthy one in this. So let's read the question. Ram is tossing a coin. If head comes up, then 10 points will be given, and if tail comes up, then 5 points will be given. And if the probability of getting exactly 30 points in total is m by n, we have to find out m plus n, and where m comma n are four prime numbers here. Okay, so I can simply count the number of cases, but I will do it in a proper way. Observe carefully. So if I assume that there are x number of tosses in which heads appears, so let x be the number of heads appearing, and let y be the number of tails appearing. Okay? So, which means the total number of points is going to be 30 here. So, since I am taking number of heads as x and then number of tails as y, now if each head will give you 10 points and each tail is giving you 5 points, I can simply make an equation here, that is 10 times of x plus 5 times of y is equals to 30. Okay? So just to make sure I won't miss any cases, first of all, I am constructing an equation. 10x plus 5y is equals to 30. Now I can start writing the cases here. First thing, if I take x is equals to 0, I will get y is equals to 6. So what is the meaning of x is equal to 0 and y is equal to 6 here? That is, there are 0 heads and 6 tails. As you can see, if there are 6 tails occurring, obviously each tail is giving you 5 points. So 6 5 30 points will cover. That is the reason I'm doing it in the proper way by constructing a linear equation here. Next, I will try to put x is equal to 1. If x is equals to 1, then this will be y is equals to 4. Similarly, let's take x is equals to 2, which means you will get y is equals to 2. And then the last possible case is x is equal to 3. In this case, you get y is equals to 0. And why is this the last case here? Because you can observe, if you put x is equals to 4, then y value is going to be negative here. So number of tails is negative, which is impossible, obviously. So only 4 cases are there. Okay. So let me write down the case 1. So what is case 1 here? 0 heads and 6 tails. 0 heads and 6 tails. So which means total number of tosses is 6 here. In that everything should be tail. But this is a unbiased point, which means probability of head is 1 by 2, probability of tail is also 1 by 2. So 6 out of 6 is going to be tails here. So it will be 6c6 multiplied by. And since you have 6 tails, each one will have a probability of 1 by 2. So it should be 1 by 2 whole to the power of 6. I hope it is clear. And then the case 2. Case 2 is what? One head and 4 tails. One head and 4 tails. So which means here you have to partition. So out of total 5 tosses in case 2, one of them must be head here. So first of all, I will pick that toss in which the head appears. So which can be picked in 5C1 ways, and then the probability of head is 1 by 2. And in all the remaining four tosses, you have to place the tail, which means it is going to be 1 by 2 whole to the power of 4. But finally, it is nothing but 5C1 multiplied by 1 by 2 whole to the power of 5. And then the case 3. So what is case 3? Look at here. X is equals to 2, y is equals to 2, which means it is 2 heads and 2 tails. Okay. So that is why you have to choose the two tosses in which heads appear out of all the four tosses, right? First of all, choose that. For C2, choosing two tosses in which heads appear. And since in those two tosses, heads must appear, each toss will have a probability of 1 by 2 as head. So it will be 1 by 2 whole square, and the remaining will be tails. That is why 1 by 2 whole square. And in total, you are going to get 4C2 multiplied by 1 by 2 whole to the power of 4. Similarly, the case 4, the final case 4 is x is equal to 3, y is equals to 0, which means you must have 3 heads and 0 tails here. So which means out of all the three tosses must be heads here. So 3C3, and each toss is having head. So probability of head is 1 by 2. Since three tosses are there, it should be 1 by 2 whole cube. Now our required answer is sum of all these cases, right? So which means required is equals to 6C6 multiplied by 1 by 2 whole power 6 plus second case is what? 5C1 multiplied by 1 by 2 whole power 5 plus third case is 4C2 multiplied by 1 by 2 whole power 4 plus fourth case is 3C3 multiplied by 1 by 2 whole to the power of 3. Now, it's a simple question, that is you have to expand and try to find out the answer, because it is being expressed as m by n, where m comma n are co-prime numbers. Okay, I think you will do the remaining part of the question, right? It's not a difficult thing, and you try to solve it and try to get the final answer. Make it as a practice to solve the question and finish the answer, right? Okay. Let's see the next question. Now this is also a direct question from binomial theorem by using a simple formula. So we have the formula for this one, that is NCR plus NCR minus 1 is equals to N plus 1 CR. So it's a pure application of this formula. It's not a difficult question, a proper solving is required, that's it. So first of all, and moreover, here we have two methods to solve this one. One is by using this formula, and other one is we have a simple trick also for this. I will discuss both the methods obviously. So whichever is comfortable to you, you can follow that, right? So let's take the method one by splitting the terms actually. So what I'm going to do is I will write this as 30C 30 minus R plus. Now I'm going to write the second term in this way. Observe carefully. I will write this as 30C 31 minus R plus 2 times of 30C 31 minus R. So I'm splitting that 3 as 2 plus 1. Similarly, in the next term also, what I'm going to do is I'm going to write this as 2 times of 30C 32 minus R plus 30C 32 minus R, and then one last term is that is 30C 33 minus R, because as you can see I'm splitting the middle terms here as sum of two terms each. The main reason is you can notice the pairs here. This is one pair and this is one pair here, and in the remaining terms also, if you take two common, it is exactly forming a pair. And all of these are following the same formula, that is NCR plus NCR minus 1 is equals to N plus 1 CR. Now, let's start applying the formula here, right? So for this one, NCR plus NCR minus 1. So this is like NCR, whereas this term here is like NCR minus 1. So what is our formula for this one, N plus 1 CR, which will give you 31C 31 minus of R. And in the similar way, I will try to solve this one also simultaneously. So once again, this term here is like NCR and this term here is like NCR minus 1. And once again, what is our formula? N plus 1 CR, that is 31C 33 minus of r. Okay. And then next thing is I can take 2 common from the remaining two terms, right? If you take 2 common, again, here this is like 30c 31 minus r. Here you can notice this one. If I take 2 common, that is also exactly in the form of NCR plus NCR minus 1. So which will give you exactly 31c 32 minus of r. Okay, now it is somewhat reduced here. And once again, what we are going to do is we are going to split and again rearrange the terms. That is, I'm going to write this as 31c 31 minus r plus I'm going to split the third term here and I will write it as 31c 32 minus r plus 31c 32 minus r plus now this term I'm going to write it here, which is nothing but 31c 33 minus of r. And what is the purpose of this? Very clearly, the first pair is also again following NCR plus NCR minus 1. Second pair is also forming NCR plus NCR minus 1. So again, I'm going to use the formula. So the first pair is going to give you 32 because n plus 1 C R. Here R is nothing but 32 minus of R. Similarly, this one also here. This is just like 32 C 33 minus of R. And once again, this is also exactly following the pattern of NCR plus NCR minus 1. I'm going to pair up this one also. And finally, what we get is here 33 n because n plus 1 C R. And here R is nothing but 33 minus of R. Okay, so finally we have reduced it to 33C 33 minus of R. And let's look at the required part. They are saying that this is equals to NCR. We have to find out the value of N. Okay. So for that, here we know that NCR is same as NCN minus R. And then I can write this as 33CR. So which means if I equate this to NCR, I get N is equals to 33. Okay. So as you can see, it is a pure application of one simple formula NCR plus NCR minus 1 is equals to N plus 1 CR. So this is one method and I will give you the method 2 also for this one. So this is a property you have to recall this from the binomial theorem actually. Now let's see the method 2 here. Method 2 will save your time by at least 2 minutes while solving. Okay. But for that you need to recall a property of Van der Monte's identity from binomial theorem. Van der Monte's identity. It's a very standard one actually from binomial theorem. So the theorem state the formula is sigma k is equals to 0 to r mck multiplied by nc r minus k is equals to m plus n c r. Direct formula, which is also derived by using binomial expansions, right? So the trick is like this. You have to add this values m and n and you have to add these values here. So as you can see, m plus n here, this will be exactly m plus n. Similarly, if you add these two, what you're going to get k plus r minus k, again you're going to get it as r. So this is how you have to remember the trick. Add these two values m and n, that will be m plus n c, and add the bases also, that is k plus r minus k, which will give you r. Okay, and here you need to rewrite the question only one single step here. So first term is what? 30c 30 minus r, right? So I'm going to write it as 3c 3 multiplied by 30c 30 minus r plus second one is 3c2 multiplied by 30c 31 minus of r plus next term is 3c1 multiplied by 30c 32 minus of r plus again last term is again 1. 1 is nothing but 3c0. 3c0 multiplied by 30c 83 minus of r. And if you try to express this as sigma notation, I hope you understood, right? I'm writing this first term as 1 as 3c3, second 3 as 3C2, next 3 as 3C1, and then last term 1 as 3C0. So that I will be able to express this entire thing as sigma notation, that is sigma k is equals to 0 to 3 3ck multiplied by 3ck multiplied by this is 30c 33 minus r minus of k. Observe carefully here. If you put k is equal to 0, you get the last term clearly. And if you put k is equals to 1, you get the last but one term. And if you put k is equals to 2, it will exactly match with second term here. And if you put k is equal to 3 here, you will get exactly the first term. 3c3 multiplied by 30c, 30 minus of k here, 30 minus of r. Okay, and that's the advantage here. As you can see, this is exactly in the form of Van der Montes identity as I just told. Look at this formula once again. Try to go through that. Now, what was the trick that I told you? Directly add these values, which will give you 3 plus 30. C, add this bottom values also directly, which will give you k plus 33 minus r minus k. So k will be cancelled out. Finally, your answer should be 33c 33 minus of r. And once again, NCR is same as NCN minus r. So which means I can write this as 33c r. And finally, this is equals to what? NCR. And finally, we get N is equals to 33 here. Okay. So if you recall this identity, it can be solved in less than 30 seconds. Okay. So try to recall this formula, and if you do not know this identity, once again you try to research about this and try to understand how I exactly did it. Okay. This is the next question. Now this is a question from continuity chapter, and the question is find the number of points of discontinuity of the function f of x is equals to step of x squared minus x plus 2 when x belongs to close to 2 to 4. Whenever you are checking continuity and discontinuity of a function, make sure you properly look at the interval there. So it is close to 2 to close to 4. And then this can be done in different ways again. And I think the easiest one is to look at the graph of the function and directly tell the answer. So let's try to do this question here. So first thing we have f of x is equals to step of, I can write this as x squared minus x plus 2 here. I can take the integer outside the step function. But I'm going to ignore this plus 2 here because it is a constant function, so it is always continuous. So this won't make any difference. Now what we have is x squared minus x. For that we have the step function. So for this, what I'm going to do is I'm simply drawing the graph of x squared minus x, and I will check how many integers are in the range of x squared minus x, and based on that I'm going to solve the question here. Okay, so I'm going to plot the graph of y is equals to x squared minus of x, okay, which is clearly passing through origin, and also it has it is passing through origin, and also you can find out the vertex here, right? So your roots are 0 comma 1 very obviously. This is 0, this is 1. And then since you are supposed to find out the discontinuities only in the interval 2 to 4, right? So let's say this is x is equals to 2 here, and x is equals to 4 is somewhere here like this. Okay. Now at x is equals to 2, let's see the output of this function here. If you put x is equals to 2, you're going to get a 4 minus 2, which is 2. This is 2 here. And corresponding to x is equals to 4, you get 4 square 16, 16 minus 4 is 12. So the corresponding output is 12. Okay. So the main thing that you have to notice in this question is in the required interval 2 to 4, this x square minus x is strictly increasing. X square minus x is a strictly increasing function. So what is the basic concept here of a strictly increasing function when you have that in the step function? All the intermediate points are going to be definitely discontinuous points. What is the meaning of intermediate points here? That is, if you notice the range of this one in this interval, it is from 2 to 12, right? So let's count how many integers are there between 2 and 12. So this is 10, 11, and similarly 9, 8, 7, 6, 5, 4, 3. So these are your integers. So let's count how many integers are there here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So clearly, in between this 2 and 12, between 2 and 12, totally 9 integers are there. So corresponding to 9 integers in the range, you will get exactly 9 inputs in the domain here, right? So which means all these 9 points are going to be discontinuous points directly. It's a simple trick that we follow, right? I hope you understand this because this is done only by looking at the graph, nothing else here. Okay. So all the points which are in the range in between 2 to 12 will definitely corresponding to those points, you get exactly 9 points in the domain, right? So all those points are going to be discontinuous, no doubt in that because it is a strictly increasing function in this case. But you still need to check it x is equals to 2 and at x is equals to 4. Okay, so here you have to be careful. And what is your function that you are taking? F of x is equals to step of x square minus x because I ignored that value plus 2, right? Because it is a constant function. Now, since 2 is the left extreme of the domain, you need to check for only the right continuity, that is f of 2 value and also f of 2 plus value. So if you take f of x as step of x square minus x here, what is f of 2 value? Which is clearly step of 4 square minus of 2, which is, sorry, 2 square minus of 2, which is equals to 2. And what about 2 plus here? Even if you put 2 plus, you're going to get something like step of 2 plus value, which is again is equals to 2. So which means at x is equals to 2, the function is going to be clearly continuous function. Okay. And then similarly, since here x is equals to 4 is a right extreme of the domain, right? Which means you have to check for only left continuity there. That is, I will have to verify only the values of f of 4 and f of 4 minus here. So what is f of 4 here? Step of 4 square minus of 4, which is equals to step of 16 minus 4, that is 12. So you get f of 4 is equals to 12. In a similar way, try to think what happens with this f of 4 minus here. If you try to put 4 minus, you can, if you want, you can take it as some 3.9 and verify. And you will be getting something like 12 minus value, a value which is slightly less than 12. But step off a value which is slightly less than 12 is going to be 11, which means you can notice that f of 4 is not is equals to f of 4 minus. So clearly this x is equals to 4 is going to be a discontinuous point. Okay. So these are all the points which we had to verify for continuity in this given domain. So totally how many points are there now? 9 points from the graph I have observed clearly, which are discontinuous points. And similarly, along with that, one extreme point, x is equal to 4 is also a discontinuous point. Okay. So in total, we get 10 points of discontinuity. And this is a question which can be done directly by looking at the graph of the function, step of graph of the function x squared minus of x. Okay. And this is easy just because the function is strictly increasing in that domain. Otherwise, it would have been somewhat lengthy to calculate and verify at each and every point. Okay, let's take the next question. It is a question related to circles and also conics right here. So a variable circle with a diameter AB where point A is 3, comma 0, touching the circle x square plus y square is equal to 36 internally. Okay, let's draw the diagram, then we will start doing the question, right? So there is a circle x square plus y square is equal to 36. So let's take that first. And clearly radius is equal to 6 units and center is nothing but the origin, right? So that thing we know very well. So I will take the center of the circle as some C1, which is origin. And then since the radius is 6, it is going to be 6, comma 0. I will take R1 is equals to 6. Now there is a variable circle with a diameter AB here, right? So the point A here is 3, comma 0, which is on x-axis between the center and the right extreme, right? Now, clearly, they said that there is a variable circle touching this one internally. I'm going to draw a rough diagram. You can see here. So this is like a circle touching the bigger one. Now, AB is the diameter, right? So let me take the point B somewhere here like this. Okay. Now, and I will assume the center of this second circle as some C2 here. Now, at last, what we have to find out the locus of center of the variable circle is also a conic whose eccentricity is E. Then find out the value of 72 into E square. Okay, so which means first thing I need to calculate the locus of this center of a smaller circle here. And let me take the radius of the smaller one as some r unit because it is not given to us. Now, we know the property very well. And one more thing, in this question, don't start assuming the center and applying the condition and expanding completely and check. It's a simple diagram based question and a simple property of ellipse. Okay. So we know the property, right? If two circles are touching each other internally, then C1, C2 is equals to modulus of the R1 minus R2. The same thing I'm going to do here. C1, C2 is equals to modulus of R1 minus R2, so which is 6 minus of R. But clearly here, 6 minus R is positive, which means I can write down C1, C2 is equals to 6 minus of R. Okay. But very clearly, this R in this diagram is nothing but the distance between the center and the point A here, as you can see in the diagram itself, which is C2A. I'm going to substitute C1, C2 is equals to 6 minus of C2A. And if I take it to the left hand side, I can write the equation as C1, C2 plus AC2 is equal to 6. Okay. Now, by looking at this equation, you would have got the idea by now. That is, it is almost similar to the definition of an ellipse, which is SP plus S dash P is equals to major axis 2A. If I am taking major axis length as 2A here. And why it is similar? Because as you can see in the question, C2 is a variable point, so which is exactly similar to this one. The C2 point in this equation which we obtain is similar to the variable point in the definition SP plus S dash P is equals to 2A. And what are the fixed points in our definition S comma S dash, which are nothing but the focus of the ellipse, right? And if you compare here, the focus in our equation obtained are nothing but point A comma point C. You can relate to that. Okay. So what are A comma C here? Point A is, I think it is given as 3 comma 0, right? So it is 3 comma 0. And this is C1. C1 is clearly 0 comma 0. So these are your focus of the ellipse. And what about the right hand side, which is 2A, major axis length? So 2A is equal to 6. Now, what is one more thing we know about this ellipse here? This SS dash value, focal length, that is the distance between the fixed point, should be is equals to 2AE, right? And here the focus are A and C1, right? So in this case, SS dash should be is equals to 2AE, which should be is equal to what is the distance between these two fixed points here? 3 units, right? Now clearly we have 2A is equal to 6. Take it and substitute. We get 6E is equal to 3. And we get finally E is equals to 1 by 2. Okay. So you don't need any assuming of center and using the expansion and again completely expanding the formulas. Not required. The simple concept of ellipse, which is the definition SP plus S dash P is equals to 2A. So if you forgot about that, try to recall the concept and try to once again watch this completely again so that you will understand properly. Okay. Let's take the next question. And this is a question from complex numbers and pure geometry based here. There is a complex number z1 which lies on the curve mod z is equals to r. So we know what is mod z is equal to r, right? Which is a circle with center at origin radius is equals to r. The problem is we don't know r value here, but it's still okay. We can do it. And Z2 lies on a curve modulus of Z minus 3 minus 4i is equals to 4. Okay. And which is also a circle, obviously. In the videos that I already posted, I already told you how to solve this kind of questions using geometry. You can go through that once again if you get any doubt here. So let's concentrate on Z2 here. Given that Z2 is lying on the curve, modulus of Z, if I take minus common, this will be minus of 3 plus 4i is equals to 5. And if you compare with our original formula, this 3 plus 4i should be the center. The center coordinates are 3, comma 4. And the right hand side is the radius of the circle here. Okay. And let me take it as R2 and the center as C1 here. And first, let us try to draw the diagram because it is a complete geometry based question complex numbers. And it is easy if you do the diagram and then try to solve the question. Okay. So since the center is 3 comma 4 and radius is equals to radius is equals to 5 units, it clearly passes through origin. Right? You can notice that the circle should be definitely passing through origin, because I think you know that if you take it as x minus 3 whole square plus y minus 4 whole square is equals to 25, origin will satisfy this one, right? So very clearly it passes through origin. And let me mark the center of this one somewhere here, C2, right? I'm sorry, C2. And then now we have to draw one more circle, mod z is equals to r. But mod z is equal to r is what again? It's center with 0 comma 0, radius is equals to r. So when you try to draw the diagram of the first circle, there are two different ways in which you can draw the circle. So one thing would be something like this, since the center is origin, right? So the first circle might be something like this. Okay, but if you take like this, what is the problem? The condition is given mod of z1 minus z2, minimum value is 2. But what is the meaning of mod of z1 minus z2 here? It is the distance between the complex numbers z1 and z2, right? Now, if you take it in this way, where z1 is lying on this circle with center at origin, z2 is lying on the other circle there, the minimum distance between those two circles is going to be 0 because they are intersecting circles. So, which means we have to make sure the first circle is drawn in such a way that it is not intersecting the second circle. Because once again, what is the simple logic? If it is intersecting circle, definitely the minimum distance is going to be 0. But as per the question, minimum distance between the 2 points z1 and z2 is 2. So which means this case is not valid here. So let me draw the proper diagram for this. So it should be something like this. I hope you understood what's the reason behind this. Okay. Now, Z1 is a complex number lying on this bigger circle here, and Z2 is a complex number lying on the smaller circle here. But obviously, we know very well the minimum distance will be occurring along the common normal, and that is nothing but the distance I'm highlighting here. You can notice this is going to be the minimum distance. Okay. And let me mark it as D minimum. D minimum is equals to 2 units. That is the minimum value given, which is modulus of Z1 minus Z2. So that is, if you pick Z1 at this point, Z2 at this point, you're going to get the minimum value, right? Now, but very clearly, that is nothing but the distance to here. So from there, what we can do is modulus of C1 minus C2. But in the diagram, we can actually notice that distance, D minimum, you can calculate like this. Look at this. This is the total radius of the circle R, whereas this distance is the diameter here. And what is the diameter of the smaller one, which is 10 units, right? So if you subtract those two, you have to get the value as D minimum here. So R minus 10 is equals to 2, which implies R is equals to 12 here. Okay. But that's not the required question, R value, because what we have to find out is the maximum distance between the 2 points Z1 and Z2. And once again, where will the maximum distance occur? If I mark it in this way, okay, you can notice here the maximum distance will be along the same common normal, but the other side. That is, you have to pick point Z1 here and you have to pick the point Z2 here. So this is going to be the maximum distance. Okay, I'm trying to highlight here. You can notice this is the maximum distance between Z1 and Z2 possible in this diagram here. Okay, let me mark it as D maximum just to be clear. And in the diagram, once again, you can calculate this D maximum using a simple logic, because this is the radius of the bigger circle, which is R. And then the other part is the diameter of the smaller circle. So if I add these two, the diameter and then the radius of the bigger circle, which will give you the D maximum. So D maximum is equals to radius R plus the diameter is 10 units. But clearly, what is the radius we have just got, which is 12 units. So 12 plus 10, which is equals to 22. So here D maximum is nothing but the distance between the two complex numbers Z1 and Z2, and that one will be the maximum. Okay. So as I told, Z1, if you take it here on the left extreme, I hope you are able to notice the diagram, and Z2 at exactly this corner here. Only in that case, along the common normal, you are going to get the maximum distance between the 2 points Z1 and Z2, and that is clearly the sum of two values, which is the radius of the bigger one and the diameter of the smaller one. And that is why it should be r plus 10, where 10 is the diameter of the smaller one. Okay, I hope it is clear. Let's take the next question. Now, this is a question from differential equations, and it is an application of linear differential equations actually. So, if you observe carefully, this is 2y square dy by dx minus of 2xy plus x square is equals to 0. And I'm sorry, this is dx by dy, right? Right. So, it should be dx divided by dy, right? So what I'm going to do is first I'm going to divide throughout by 2y square, so that I will get this as dx divided by dy minus of, since I'm dividing by 2y square, it should be x divided by y, and plus x square divided by 2y square is equals to 0. Then I'm going to divide throughout by minus 1, minus 1 by x square. So if you do that, this will be minus 1 by x square dx by dy, and plus 1 by x into 1 by y plus and minus, sorry, minus, since I'm dividing by minus x square, this will give you minus 1 by 2y square is equals to 0. And what is the main advantage by doing this here? As you can see, if I try to put 1 by x is equals to t here, the question changes to a proper linear differential equation. Put 1 by x is equals to t, so which makes this entire first term as dt by dy. If you differentiate with respect to y here, so it becomes dt by dy, and plus 1 by x is t, so t into 1 by y, and if you take it to the right hand side, this will be 1 by 2y square. Okay. So clearly you have a proper linear differential equation in terms of t and y. Now you know what to do, right? First thing is you have to calculate the integration factor here. So integration factor will be nothing but here e to the power of integration of t of y. T of y is 1 by y, so dy. So you get e to the power of ln y, and that is nothing but y. Okay. And then you know how to write on the solution of this one. So which should be t into integration factor is equals to integration of this right hand side q of y, which is 1 by 2y square multiplied by if multiplied by dy. And then to solve this question, you know what to do. Directly put this if here, and you will get one constant term also after integration. And to get that constant term, they gave you one condition, x of e is equals to e. So put that condition, you will get the constant c also. And then at last, what we have to find out is 3 times of x of e square. But what is the meaning of x of e square here? The value of x when y is equals to e square, because this is a function in terms of x in terms of y here. Okay, so what is the meaning of x of e square again? We have to find out the value of x when y is equals to e square. So put that y is equal to e square here and try to find out the x value and substitute and verify. Okay, and since it is an easy process which is very well known to you, I'm leaving the calculation part to you and try to solve the remaining part. Okay, let's take the next question. Now this is a question from relations chapter. So the only thing that we can do here is start writing the cases for this one. So it will take some time, but let's read the question first. Capital A is equals to set containing 2, 3, 4, 5, 6, and capital R be a relation on A cross A such that x comma y capital R A comma B implies x is dividing A. Okay, so let me mention that condition first of all. So the relation R here contains order pairs in this way, x comma y capital R A comma B, that is x comma y ordered pair is related to the ordered pair A comma B if and only if it is satisfying two conditions. The first condition here is x divides A, that is x is factor of A, and the second condition is y is less than or equals to B here. Okay, So let's try to see in how many ways you can put the values of x and a together. So first, since x is a factor of a, I will start from x is equals to 2. Okay. So if x is equals to 2, what must be the values of a here? So since x is a factor of a, which means I can say a must be multiples of 2. But in the given set a, what are the multiples of 2 available? Which are clearly 2, comma 4, comma 6, right? So in this case, you get three possibilities. Similarly, let's start x is equals to 3 now. So in this case, a must be a multiple of 3. So what are the multiples of 3 available? Which is clearly 3 and 6. And if I put x is equals to 4, there is only one multiple of 4, which is 4 exactly. No other values are there. And I can take x is equals to 5, and still you get same thing, a is equal to 5, because no other possibility, no other higher multiples are there. Similarly, x is equal to 6 will give you a is equals to 6. Okay. So if you totally count it, how many cases are there? Here three cases, here two cases, only one order, one possibility, one possibility, one possibility, which will give you totally how many? 3 plus 2, 5, 5 plus 3, 8. So which means there are 8 ways in which you can place the values x and a in that relation. Okay. But we still need to calculate how many combinations of y and b are also possible here. And but here y is less than or equals to b, right? So which means if I put y is equals to 1, then we need to count how many values of b are possible. So if I take y is equals to 1, b must be greater than equal, sorry, y is equals to 2, right? I'm sorry, because 1 is not there in the set A. So if I start putting y is equals to 2, since b greater than equals to 2 here, b can be 2, 3, 4, 5, 6, which will give you 5 possibilities. Similarly, y is equal to 3, if I put, I'll get b is equals to 3, 4, 5, 6, which will give you 4 possibilities. Then y is equals to 4 will give you b is equals to 4, 5, 6, which is exactly 3 possibilities. And y is equal to 3, you get b is equals sorry, y is equals to 5, you get b is equals to 5 comma 6, and y is equal to 6 will give you only one possibility, b is equal to 6. Okay. So let us check how many combinations of y and b are possible. 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 14, 14 plus 1, 15. Okay. So which means this x and a combinedly can be put in 8 ways totally, and then y and b combinations are totally 15 in number. So which means the total number of combinations in which you can put x comma y related to a comma b is 15 into 8, which should be is equals to 120. Okay. So this is how you do the question, right? And I hope it is clear. It is a simple question, but as I told, the only thing is writing proper cases is required, right? Let's take the next question. And this is a question somewhat similar to the question which appeared in shift 1. I discussed that question also in the previous video. You can go through that once again if you have not seen. So here there is a set P which has values theta belonging to close to 0 to 4 pi. And also it has to satisfy two conditions here. That is tan square theta is not as equals to 1. And more importantly, we have the condition 2 into cos power 8 theta minus sine power 8 theta multiplied by secant of 2 theta is equals to a square, and more importantly here a belongs to integers. Okay. So once again what you are going to do is you are going to solve the left hand side part first, then we try to get the values of possible values of a. Okay, so let us do that. I think you would have noticed the idea by now. First thing I can write this as cos power 4 theta minus sine power 4 theta multiplied by, this is cos power 4 theta plus sine power 4 theta multiplied by secant of 2 theta, which is equals to a square. But once again, I can further write this cos power 4 minus sine power 4 as what? Cos square theta plus sine square theta multiplied by cos square theta minus sine square theta, right? But very clearly, the square theta plus sine square theta will be is equals to 1. And what about this cos square theta minus sine square theta? Very clearly, it is cos of 2 theta. So let us rewrite the entire equation once again, which reduces to 2 into cos 2 theta multiplied by, and once again I'm going to write this cos power 4 plus sin power 4 theta as nothing but what? I can write this as cos square theta plus sin square theta whole square minus 2 into sin square theta into cos square theta. Okay. So which is nothing but 1 minus of 2 sin square theta cos square theta multiplied by secant 2 theta is equals to a square. Okay. But since we have secant 2 theta here, we have to put one condition that 2 theta cannot be is equals to odd multiples of pi by 2, because that is the domain, right? And which means theta cannot be kept as odd multiples of pi by 4. Okay, so let's keep that in mind. This is going to play an important role while deciding the final answer. Okay, and then since we put the condition that theta cannot be is equals to odd multiples of pi by 4, I can cancel this secant to 2 theta and cos 2 theta, and then the remaining part. What's the remaining part here, which is 2 times of 1 minus of 2 sin square theta into cos square theta is equals to a square. But I can further simplify this one. I can write this as 2 times of, now clearly it is 4 sin square theta cos square theta, right? So I can write down 4 sin square theta cos square theta is nothing but a sin square 2 theta, which is equals to a square. Okay. Now, very important thing is they gave a belongs to integers here. So obviously, you have to check how many values of a are possible for this trigonometric equation to be a valid equation with solutions. Okay. So for that, you can notice that this sine square 2 theta will have a range of what, 0 to 1. And then since it is minus sign, let's calculate here. If you want, I can write it here. Sine square 2 theta lies in between 0 to 1. And if you multiply it throughout by minus 1, you're going to get 0 greater than equals to minus the sine square 2 theta greater than equals to minus 1, and add 2 to this one. So 2 greater than equals to 2 minus the sine square 2 theta greater than equals to 1. Okay. So which means here this value of a square, this value of a square, I hope you're able to notice this. I'm taking this value of 2 minus sine square 2 theta and substituting it here. Okay. So what we get is 2 greater than equals to a square greater than equals to 1. Okay. So which means a square value should be lying in between 1 to 2. Moreover, what is a here? Very important thing. A belongs to integers. So if a belongs to integers, what is the only possibility here? I can say that a is equals to 1 is the only possibility. This a is equal to plus or minus 1 is the only possibility, right? Because that is the only possible, those are the only possible integers which will satisfy this inequality. No other value will satisfy. 0, 2, anything will not satisfy. Now let's take this a is equal to plus or minus 1 and substitute it back here. So from which you get 2 minus a sine square 2 theta is equals to 1. So finally, what we get is a sine square 2 theta is equals to 1. Okay. And if sine square 2 theta is equals to 1, we know what to do. That directly it is nothing but 2 theta should be is equals to n pi plus or minus pi by 2. N pi plus or minus pi by 2, because it can be plus pi by 2 minus pi by 2. It can be plus 3 pi by 2 minus 3 pi by 2. It can be anything, right? So it should be n pi plus or minus pi by 2. Finally, we get theta is equals to n pi by 2 plus or minus pi by 4, where n belongs to integers here. So this is your general solution. For example, if I put n is equals to 0, you get theta is equals to plus or minus pi by 4. And if I put n is equal to 1, then I will be getting pi by 2 plus or minus pi by 4, which is nothing but again pi by 4, or pi by 2 plus pi by 4 will be 3 pi by 4. And let's say I'm putting n is equals to 2. Then I will get pi plus or minus pi by 4, which is nothing but pi pi by 4 or 3 pi by 4. So very clearly you can notice that when you start writing the solutions of this equation, you are getting all odd multiples of pi by 4. All are odd multiples of pi by 4. But if you observe the question here, I already told you one thing, Here theta cannot be is equals to odd multiple of pi by 4 because theta cannot be is equals to 2n plus 1 into pi by 4 because the term secant 2 theta was there. The 2 theta can never be is equal to odd multiple of pi by 2, which means theta cannot be odd multiple of pi by 4. So, which makes the final conclusion here as null set because when solving this equation, you are getting each and every solution which is an odd multiple of pi by 4. But that is not possible because in that case, the secant 2 theta will not be defined actually. And one more thing here in the question already they gave you tan square theta cannot be is equals to 1, which means once again here theta cannot be an odd multiple of pi by 4. Okay. Theta cannot be an odd multiple of pi by 4. Directly you can tell, right? For example, tan square theta not is equals to 1 means theta cannot be like plus or minus 4, plus or minus 3 pi by 4. It cannot be odd multiples of pi by 4. So, which means there is no common solution to this trigonometric equation. So, the question is finding number of elements in the set P, which is 0 null set, not even possible, right? I hope it is clear. So these are the questions which I wanted to discuss from the afternoon shift of 2nd April and which I found interesting. And some questions I gave you the tricks also directly to reduce the calculation time, right? So if you found any other questions interesting and which I did not discuss here, you can put that in the comment section. So whenever I find time, I can make a video out of that. Okay. So I hope it was very helpful to you guys. Okay. So when the next shift starts, then I will post the video related to that one also. Okay. Thank you.